Math 102, example 3.7.1. So we've solved rational equalities. Now let's look at inequalities. If you remember how we solved quadratic inequalities, a lot of these steps are going to sound pretty similar. So our first is to solve this as if we had an equal sign. And in fact, you can write it as an equal sign if it helps. So we said in our last section that to multiply, or to solve, we multiply both sides by that denominator. But what's going to happen as I do that? It cancels on the left, and 0 times anything is 0. Our first step then, we are basically taking the numerator equal to 0, assuming we have a 0. And that gives me a -1 as a solution. Now, we can never forget the domain. That is the big thing we want to worry about. So again, for the domain, we set the denominator not equal to 0. And here I get x is not 4. You can find those two numbers in the opposite order, but those two numbers are numbers we do need to find. So now that I have them, let's set up a number line. There's the -1, there's the 4, and let's check intervals. So again, I pick any number less than -1. I'm going to pick -2 just for simplicity's sake. And if we plug that into our inequality, let's see what we get. I get -1 over -6, which is +1/2. Is that greater than or equal to 0? Yes. So let's put a yes there. Between -1 and 4, let's pick 0. 0 is usually a pretty easy number. Is that greater than or equal to 0? No. And then I need a number greater than 4. Let's pick 5. And I get 6 over 1. And yes, that is greater than or equal to 0. Now, as we had with quadratics, you can use the number line, but I recommend using the calculator to help. So on the calculator, again, I'm not graphing the inequality. I'm graphing just the function, just the left-hand side. And again, I've got parentheses around the numerator and parentheses around the denominator. So let's graph that. And I'm going to draw this up here on my notes as well, so we can talk about this in detail. 2, 3, 4. Ooh, that's not the best drawing I've ever done. Let's make that more like that. There we go. Now, the -1, this is where we crossed the x-axis, and at +4, that's where we've got our vertical asymptote. So again, you can look at those and hopefully see them from the graph. You can also use the table. If I go to my table at -1, that's where I've got the 0. And scroll down just a little bit so I can see the 4. There's the error message. Again, that error message is my vertical asymptote. Now, to get the actual result, though, I have to interpret this graph. So I want to know where it's greater than 0. So in other words, where it's above the x-axis. So I'm above the x-axis over here on the left-hand side. And then this entire right-hand side piece as well. The only piece we aren't above 0 is there in the middle. So my answer is -∞ to -1. Remember, we use the u if we have two intervals. And then 4 to +∞. Now my infinities and negative infinities take parentheses as usual. And I'm going to put a bracket at -1. But I put a parenthesis at -4. That's because, or I'm sorry, at +4. That's because that's where we had division by 0. We are not allowed to have division by 0. So if the number came from the denominator, in my answer, it must have a parenthesis. Again, we are not allowed to include that number. Now, these are less predictable than our other inequalities simply by the nature of them being rationals. So I always recommend get a picture. That picture will hopefully help you see clearly where it is and is not greater than or less than 0, depending on what we're looking for.